Hello and welcome. I need to tell you about something that has been happening for the past 4 months, and I need you to understand why scientists are struggling to explain it. There is an object moving through our solar system right now. It came from beyond our sun's influence. It came from the space between stars, and for 122 days straight, this object has been doing something that natural objects should not do. Something is changing about it every 6 hours and 41 minutes. The same interval, the same percentage over and over like a clock. And after 16 weeks of continuous observation, the world's best scientists still cannot tell us why. Let me be clear about what I mean by stabilize. When you point a telescope at a distant object and measure it, the numbers settle. They might change slowly over time as conditions change, but they settle into a pattern. Think of it like measuring the temperature of a room. It might go up or down, but it finds a range. It behaves predictably. That is what stable means. That is what every object in space does. Asteroids, comets, planets, stars, they all stabilize. This object does not. The object is called 3I Atlas. Scientists at NASA's Jet Propulsion Laboratory have been tracking it since July. And there is one measurement, one single variable in all their data that will not hold steady. Every other reading stabilizes. This one does not. The variable I am talking about is brightness, how much light this object reflects back to our instruments. And it is changing in a way that makes no sense. Every 6 hours and 41 minutes, the brightness shifts, not by a little bit, by 47%, then it drops. Then it rises again, exactly 6 hours and 41 minutes later. This has happened continuously for 4 months, over and over. The same interval, the same percentage change for 122 days straight without a single deviation. I want you to think about what that means. Natural objects in space do tumble. They rotate as they spin. Different surfaces point toward Earth and brightness changes. We see this with asteroids all the time. But natural tumbling does not produce exact intervals, it does not repeat with this kind of precision, and it certainly does not maintain the same percentage change for 4 months without any degradation. Natural processes are messy, they vary, they slow down, they speed up. This does not vary, this repeats like a clock. The team at JPL ran calculations. If this brightness change comes from rotation from the object tumbling through space, then its shape would need to be extremely elongated, like a cigar or a needle. The ratio they calculated was 10.1. That means if this object is 100 minutes wide, it would need to be 1,000 minutes long. That is unusual, but not impossible. We have seen elongated asteroids before. But here is the problem. An object shaped like that tumbling freely in space would not maintain such a precise rotation period. Not for this long, something would disturb it. A tiny gravitational pull outgassing if it has volatiles pressure from solar radiation. Over 4 months, the period would drift even by a few minutes. But it has not drifted, not by 1 second. Leading astronomers began suggesting alternatives. Maybe the brightness change is not from rotation. Maybe it comes from material coming off the surface, jets of gas or dust. We saw this with Oumuamua, the first interstellar object discovered back in 2017. Oumuamua showed strange acceleration that scientists eventually attributed to outgassing, even though we never saw the gas directly. Could the same thing explain 3I Atlas? Could jets firing at regular intervals cause these brightness pulses? The European Space Agency examined that possibility. They used satellites equipped to detect specific wavelengths of light, the signatures of molecules like water vapor or carbon dioxide or methane. These are the substances that create jets when they heat up and turn to gas. If 3I Atlas was outgassing, these instruments would see it. They pointed their equipment at the object. They collected data for 3 weeks straight. They found nothing. No water signature, no carbon dioxide, no methane, no cyanide, no ammonia, nothing. The object is not releasing gas that our instruments can detect. That created a deeper problem. If the brightness pulses do not come from shape and rotation, and they do not come from jets of material, then where do they come from? What mechanism operating in the vacuum of space on an object with no atmosphere and no detectable outgassing could produce such regular dramatic changes in reflected light? Some researchers proposed surface composition. Maybe one side of the object is covered in dark material that absorbs light, while the other side is covered in bright material that reflects it. As the object rotates, we would see brightness changes. That could work, but it would still require rotation. And we are back to the same problem. Why is the rotation period so stable? Why has it not changed even slightly in 4 months? And here is another question. What natural process creates such a sharp divide in surface composition? Why would one hemisphere be so different from the other? It is not impossible, but it requires a very specific formation history. And even then, it does not explain the precision of the timing. The director of the Gemini Observatory in Hawaii made an important observation in October. He noted that the 6-hour and 41-minute period is unusual for another reason. Most asteroids that size rotate much faster. Small rocky bodies typically spin every few hours or even every few minutes if they are really small. But 3I Atlas is estimated to be about 200 mm across based on its brightness. An object that size formed naturally would likely spin faster than 6 hours and 41 minutes. Unless something slowed it down, unless it experienced some event that altered its rotation. But what event? And why would it produce such a specific stable result? In November, a team of physicists ran simulations. They wanted to see if any combination of natural factors could produce what we are observing. They modeled tumbling motion. They modeled outgassing. They modeled different shapes, different compositions, different formation scenarios. They ran thousands of variations, and they found that yes, you can get brightness variations, yes, you can get periodic changes, but you cannot get this level of precision maintained over this length of time. Not naturally. Every simulation showed drift. Every simulation showed the period changing even by tiny amounts, but the real object does not show drift. The real object maintains 6 hours and 41 minutes exactly. I must tell you what that means. It means that either we are missing something fundamental about how objects behave in space, or this object is not behaving naturally. Those are the two possibilities. Either our physics is incomplete or something else is happening, and physicists do not like to say their physics is incomplete. They test it endlessly. They refine it constantly. The rules that govern rotation and gravity and light are among the most tested, most reliable rules we have. If those rules are wrong, it would overturn much of what we think we know. That is not impossible. Science has been wrong before, but it requires extraordinary evidence. The alternative is harder to discuss. I have been watching astronomical developments for many years. I have seen scientists debate unusual objects before, and there is always reluctance to suggest anything beyond natural explanations. That reluctance is healthy. It prevents us from jumping to conclusions, but it also means that when something truly anomalous appears, there is a delay. A period where everyone tries every possible natural explanation first. Sometimes that delay lasts years. We are in that delay right now with 3I Atlas. But let me present some facts. This object came from interstellar space. That is confirmed. Its trajectory shows it did not originate from our solar system. It came from the direction of the constellation Lyra, moving at a speed that proves it was not bound to our sun. That makes it only the third confirmed interstellar object ever detected. The first was Oumuamua in 2017. The second was Comet Borisov in 2019. Now we have 3I Atlas, 3 objects in 8 years. Before that, we had detected none ever. That tells us interstellar objects are more common than we thought, or our detection capabilities have improved enough to finally see them. Probably both. Oumuamua caused enormous debate because it also showed unusual properties. Its shape appeared extremely elongated. It showed unexpected acceleration. Some scientists argued it was a comet without gassing we could not see. Others, including researchers who study these objects, suggested it could be artificial, a piece of technology from another civilization. That suggestion was controversial. Many scientists rejected it, but the debate revealed something important. We do not actually know what artificial objects from other civilizations would look like. We have no reference. We only know what natural objects look like. And when something does not fit the natural pattern, we are left guessing. 3i Atlas does not fit the pattern. The brightness variations are the most obvious anomaly, but they are not the only one. The object spectrum, the specific colors of light it reflects, shows an unusual composition. It is not quite like asteroids. It is not quite like comets. It sits in between. Some researchers suggest it might be made of materials we rarely see, organic compounds perhaps, carbon-based molecules. That would be interesting scientifically, but it would not explain the precision timing of the brightness changes. There is also the question of where it came from. The trajectory points back toward Lyra, but that does not mean it originated there. Space objects travel for millions of years. They come from stellar systems that have long since moved. Astronomers tried to work backwards to calculate where this object might have been thousands or millions of years ago. They found several possible origin points, small dim stars where a planetary system might exist. But the calculations have huge uncertainties. We cannot say with confidence where it came from. We only know it was traveling through the space between stars for a very long time before we saw it. How long? Based on its speed and likely distance covered, this object has been traveling for at least 1,000,000 years, possibly much longer. Think about what that means. If this object is artificial, if it was built by some civilization, then it was built at least 1,000,000 years ago, and it has been moving through space alone all that time, still functioning, still producing these regular brightness pulses. That seems impossible. What technology could operate for 1,000,000 years without maintenance, without repair in the harsh radiation environment of interstellar space? Natural objects can survive that long. Rocks last billions of years, but natural objects do not produce precise repeating signals. They do not maintain stable rotation periods over months of observation when physics says they should drift. They do not refuse to stabilize. NASA assigned higher priority to tracking this object in late November. That means more telescope time, more resources dedicated to observation. That decision tells me they are taking the anomalies seriously. Organizations like NASA do not redirect expensive equipment without reason. They have limited time on the best telescopes. Every hour spent on 3i Atlas is an hour not spent on other important research. They made that trade. What does that tell you? I made inquiries with colleagues in the astronomical community. I wanted to know if there were aspects of this object not being discussed publicly. One researcher told me that there are additional measurements beyond brightness, measurements of polarization, that is, the orientation of light waves as they reflect off a surface. Natural surfaces produce random polarization. Light bounces off in all directions with no pattern, but some artificial surfaces, particularly smooth metallic ones, can produce organized polarization. Light waves align. I asked if 3i Atlas shows organized polarization. My colleague would not answer directly. He said the data is still being analyzed. That tells me something. If the polarization were random, he would have said so. If it showed something unusual, he would not discuss it yet. I am not saying this proves anything. I am saying there may be more to this story than the public data shows. The SETI Institute also expressed interest in October. The search for extraterrestrial intelligence focuses on finding signals from other civilizations. Usually they listen to radio waves, but they also investigate unusual objects that might have artificial origins. They requested data from observatories tracking 3i Atlas. They wanted to examine the light curve, the pattern of brightness changes, to see if it contains any information, any pattern beyond simple repetition. Could the brightness pulses encode something? Could the 6-hour and 41-minute interval mean something? Natural processes do not encode information. They do not send messages. Pulsars send radio pulses at precise intervals, but those pulses come from rotation from beams of radiation sweeping past Earth like a lighthouse. We understand the mechanism. With 3I Atlas, we do not understand the mechanism, and if we do not understand it, we cannot rule out that it might be doing something purposeful. Let me be clear about what I am and am not saying. I am not claiming this object is artificial. I am saying the data we have does not fit natural explanations well. I am saying that scientists who study these objects are paying close attention because the measurements are unusual. I am saying that after 4 months of observation, the same variable that was unstable in July is still unstable now, and precision that high maintained that long is something we do not see from natural tumbling rocks. There is a concept in science called Occam's razor. It says that the simplest explanation is usually correct. When you hear hoofbeats, think horses, not zebras. Natural explanations are simpler than artificial ones. A rock tumbling through space is simpler than a device built by an alien civilization. So, we should prefer the rock explanation. We should only consider artificial origins when every natural explanation fails. That is the responsible approach. That is what scientists are doing right now. They are testing every natural explanation they can think of. They are trying to make the natural explanations work. But there comes a point where the natural explanation requires so many special conditions, so many unlikely factors all occurring together that it stops being simpler. If you have to propose a very specific shape and a very specific composition and a very specific formation event, and a very specific reason why rotation has not drifted, and a very specific reason why outgassing is not detected, and a very specific explanation for the unusual spectrum, then maybe the simple explanation is not so simple anymore. Maybe it has become complicated. The object's thermal signature also raised questions. Infrared telescopes measured how much heat it radiates. Every object in space absorbs sunlight and re-radiates it as heat. The amount of heat tells us about surface properties. Is it rocky, icy, metallic? The thermal measurements of 3I Atlas showed something unexpected. The object is cooler than it should be, based on its distance from the sun. Not dramatically cooler, but measurably cooler by about 15%. That suggests the surface is either highly reflective, bouncing sunlight away before it can heat up, or the object is radiating heat very efficiently. Highly reflective surfaces are unusual for asteroids. Most asteroids are dark. They absorb most of the light that hits them. That is why they are hard to see. A highly reflective asteroid would be brighter and easier to detect, but it would also need to be made of materials that are naturally reflective, ice perhaps, or certain minerals. The spectrum of 3I Atlas does not show strong ice signatures, so what is making it so reflective? Smooth metal would do it. Polished surfaces reflect light efficiently, but natural space rocks are not polished. They are rough-pitted by impacts and radiation unless this object formed differently, unless its surface had some reason to be smooth. The other explanation is efficient heat radiation. Some materials radiate heat better than others. Metals are good at this, dark materials are good at this, but the spectrum does not show a purely metallic composition. It shows that mix of properties I mentioned earlier, not quite asteroid, not quite comet, something in between. That unusual composition might explain efficient heat radiation, but it adds another layer to the mystery. Why would an interstellar object have this specific mix of properties? What formation environment produces that? In December, astronomers at the Keck Observatory in Hawaii conducted detailed spectroscopic analysis. They broke the light from 3I Atlas into its component wavelengths, looking for absorption lines. These are dark bands in the spectrum where specific atoms or molecules absorb light. Every element has a unique signature. By identifying which absorption lines are present, we can determine what the object is made of. The Keck data showed something interesting. There are absorption features consistent with organic compounds, complex carbon-based molecules. These are not uncommon in space. Comets have them, some asteroids have them, but the specific pattern of absorption lines did not match any known asteroid or comet exactly. It was close, but not identical. That could mean the object contains organic compounds in different proportions than we usually see. Or it could mean the compounds are arranged differently on the surface. Or it could mean there are additional materials mixed in that we have not identified yet. The researchers who analyzed this data said more observations are needed. They cannot make definitive conclusions from one set of measurements, but they noted that the unusual spectrum adds to the growing list of properties that do not quite fit expectations. There is also movement to consider beyond the brightness variations. There are questions about the object's trajectory. When it entered our solar system, it followed a hyperbolic orbit. That means it came in fast enough that the sun's gravity could not capture it. It will swing around the sun and head back out to interstellar space. That is normal for interstellar objects, but the exact path matters. Small forces can alter trajectories. Outgassing creates thrust. Radiation pressure from the sun pushes on objects. Gravitational pulls from planets tug at passing visitors. All of these affect the path. Astronomers measured the trajectory very carefully. They wanted to know if 3I Atlas is following the path it should follow based on gravity alone, or is there some additional force acting on it? With Oumuamua, there was additional force. The object accelerated slightly more than gravity predicted. That is what led to the outgassing explanation. With 3I Atlas, the trajectory so far looks normal. Gravity seems to account for the path, but the object is still relatively close to the sun. As it moves farther out, if there is any non-gravitational acceleration, it will become more apparent. Scientists are watching for that. If the object starts deviating from its predicted path, that will be another data point, another piece of the puzzle. Think about what we have so far. An object from interstellar space. Unusual composition, unusually reflective surface, unusually cool temperature, brightness variations that repeat with impossible precision, no detected outgassing, no clear natural explanation for the brightness pattern, and scientific institutions dedicating significant resources to observation. This is not normal. This is not how routine asteroid observations go. There is something about this object that has captured serious scientific attention. I have been following space science for a long time. I have seen excitement over new discoveries. I have seen debates about unusual findings, but I have rarely seen this level of sustained focus on a single object that we cannot explain. Usually when something unusual appears, scientists figure it out within weeks or months. They gather data. They test hypotheses. They reach consensus. That has not happened here. 4 months in, there is no consensus. There are competing ideas, but none that fully satisfy the observations. The brightness variations remain the central mystery. If we could explain those, everything else might fall into place, but we cannot explain them. Not with rotation, not with outgassing, not with surface composition alone. The precision is too high, the stability is too perfect, and every day that passes without drift, without any change in the 6-hour and 41-minute period, makes natural explanations harder to accept. Some scientists are considering combined explanations. Maybe it is rotation and surface composition working together. Maybe the object has an unusual shape and unusual materials, and together they produce this pattern. That is possible, but it still requires explaining why the rotation is so stable, why it has not changed at all, and it requires proposing a very specific set of circumstances that all happen to align perfectly. That is not impossible. Nature can be specific, but it is becoming less and less likely. I want to be honest with you about something. There is a part of me that hopes this object is just a rock, a weird rock with unusual properties that we will eventually understand. Because if it is not a rock, if it is something else, that changes everything. That means we are not alone. That means other civilizations exist or existed. That means technology can survive for millions of years crossing the space between stars. That is profound. That is overwhelming. And I am not sure humanity is ready for that revelation. But what I hope is not relevant. What matters is what the data shows, and the data shows an object that does not behave the way natural objects behave. The data shows precision that we associate with mechanisms, with devices, with intentional systems. The data shows that very smart people with very good instruments are confused. What happens next? The object is moving away from the sun now. It is heading back out toward interstellar space. Every day it gets farther away. Every day it gets dimmer and harder to observe. We have a window, maybe a few more months, where the best telescopes can still see it clearly. After that, it will be too faint. It will disappear into the darkness between stars, just like Oumuamua did, and we may never get another chance to study it closely. That creates urgency. If there are additional observations to make, additional measurements that might answer these questions, they need to happen soon. NASA knows this. The European Space Agency knows this. That is why resources are being directed toward this object now. Not next year, now. Because the opportunity is limited. Because once it is gone forever. We cannot chase it. We cannot send a probe fast enough to catch up. We can only watch while it is close enough to see. I think about what future astronomers will say when they look back at this moment. Will they say we detected an unusual interstellar object and could not explain it? Will they say we found evidence of another civilization and missed it? Will they say we learned something new about how natural objects behave that changed our understanding of physics? I do not know which story they will tell, but I know this is an important moment. Objects like this do not appear often. When they do, we should pay attention. The brightness is still changing. Right now, as you hear this, that object is out there in space, getting farther from us every second. And every 6 hours and 41 minutes, its brightness shifts by 47%. It has done this thousands of times since July. It will do it thousands more times before it leaves our view, and we still do not know why. We still cannot explain it, and that should concern us, because in science, when you cannot explain something with the tools you have, it usually means one of two things. Either your tools are inadequate or you are looking at something fundamentally different from what you expected. I encourage you to follow the developments on this object. The scientific community is watching it closely. New data arrives regularly. Papers will be published. Debates will continue. And maybe eventually we will have an answer. Maybe someone will find the natural explanation that fits all the data. Maybe the precision will turn out to have a cause we simply had not thought of yet. Or maybe we will have to accept that we are seeing something we have never seen before. Something that came from another star system. Something that challenges our assumptions about what exists out there in the darkness between stars. This matters. Questions about objects from interstellar space are questions about our place in the universe. They are questions about whether we are alone. They are questions about what else might be traveling through space right now undetected because we are not looking in the right places or at the right times. 3i Atlas may be unusual, but it is probably not unique. If objects like this exist, there are likely others. We just have not seen them yet, and the more we look, the more we will find, and each one will teach us something, each one will challenge us, each one will force us to ask harder questions. Thank you for listening. I will continue to monitor this situation as it develops. The story of 3i Atlas is not over. It is still being written, and I believe it is a story that deserves our full attention.